In today's session, we're going to take a look at various topics and subjects that we can take a look at or consider in terms of data visualization and analysis using various tools. For example, in today's session, we are not going to only take a look at Python. We are going to take a look at Python, Power BI, and SQL, and how all of these things can orchestrate together to drive a better data visualization and better analysis and subsequently a more advanced decision based on the data that you're going to drive from these types of solutions. Please, while I am conducting this webinar, please, if you have any question, you can feel free to ask in the chat box. Meanwhile, we are going to progress in this session. So first of all, I am Nashat Omar. I have been working in oil and gas industry for more than 11 years. So far, I have trained more than 1,000 engineers on different topics. More precisely, on Python topics, we have more than 400 people trained and other 200 or 300 people trained on various data analysis and data science techniques. I have been working with programming since the college. Plus, I have experience in different oil and gas industry standard softwares like OFM, PipeSim, IPM, Olga, and what's not. So why you should join any particular data science or data analysis training to be more precise? Python usually is the center stage of these types of training. And this is for a good reason. You will see why Python is usually the, let's say, the main suspect whenever any type of this training is usually delivered. But it does not have to be that way. Python have its own, let's say, its own traits that basically leads to a good solution that usually an engineer creates. So basically, whenever you use Python or whenever you join any particular training that teaches you how to put your hands on these types of problems and convert those into solutions using Python or other sets of tools, usually you will have a fundamental understanding how different problems in oil and gas industry will be approached. Plus, once you join these types of training, you will understand how different data sets can be funneled into these types of solutions. For example, I meet lots of engineers, they don't know how to actually harness or utilize these types of data. For example, maybe they have data sitting in Excel, maybe they have data sitting in text files. So you have different sources of data basically are thrown around in oil and gas companies. It does not have to be complicated. Python actually, or these types of software that allows you to visualize and analyze, actually will allow you to handle these types of text files for you. Plus, you can solve problems or create solution to existing problems if you have the right tools and the right understanding. Plus, you will understand that Python is just basically the beginning of this type of journey. For example, once you learn Python, you will see that Python is just it's basically is very similar to cooking. Whenever you understand how cooking works, with different ingredients, you can create actually different types of recipes. And Python is just like this. For example, if you learn, for example, let's say the basics of Python, now out of a sudden you can convert that into a data science, or you can create that into trend analysis, or you can convert that into solutions for petrotechnical analysis, or you can even create machine learning and artificial intelligence solutions. So basically, just Python is the key to different solutions, by the way. Now, what's the kind of impact these types of tools will have on your career? Actually, there are lots of things that you can benefit from these things. I'm not going to go on into all of these points. I will just highlight the most important ones. For example, the most important thing that you can get from these types of things is actually the career improvement and advancement you will get. That's number one. Number two, you can automate few things that you have lying around in your workflow. For example, maybe you're doing some repetitive task. Maybe you want to improve that task. Maybe you want to generate many hundreds of images, or let's say plots or charts at the same time. If you would do that usually in Excel, it will take lots of times. But in Python and using other tools, you can actually automate this process fairly easily. For example, you can integrate different oil and gas softwares into Python. For example, you have Gap, you have Prosper, you have PipeSim, you have petrophysical suites like Geolog, TechLog, these all of these softwares actually they integrate seamlessly into Python nowadays. Plus, if you're working with OZPy or OZ Server or Pi Server or PyVision, these types of software or these types of digital oil field tools, they usually allow you to connect to Python. And plus, once you know Python, you can connect or you can harness the data that you get from the databases to create a real-time solutions. So there are lots and lots of things that you can do and you can learn that basically they will have a huge footprint on your career, because all of these things will funnel down into a particular solution that might help you and might help the operator that you're working with. So Python as a language is not a new one, or it's not a recent one. It's been around for more than 33 years, and it's used for lots and lots of things nowadays. It's used for creating web applications. Nowadays, these are known as data applications. Data applications are the applications that you usually use for data analysis, and they sit on the website. Python is actually one of these languages that are using people are using to create these types of software. For example, Meta, or let's say Facebook and Instagram, basically they use Python on the back end to create all of these data analysis solutions and then present those back into the application. People use this for software development to create different types of software. People use it for in the academia for mathematics instead of MATLAB, because it's free, it's easy to use. It's everything that you want. Lots of people use it for data science. Data science is basically it's a big umbrella that holds, or let's say that contains data analysis, data visualization, data handling, data manipulation, and all of these things they usually called data science. Plus, you can use these for engineering and computation designs and basically the other different things. What makes Python a very strong, or what makes Python a very good solution to these types of problems is basically Python is free, it's easy to learn, it's easy to share the code. Plus, there are large number of libraries that you can use. A library is basically a piece of code that someone wrote at a particular time and decided to publish that online on the internet. You can harness that person's actually efforts and then use that into your in your own code. For example, we have been using these techniques of external libraries in oil and gas industry for the past 15 years now, and it accelerated the oil and gas projects basically using Python a lot. It makes them the development cycle a lot faster, and the solutions that were created around the data are much more faster to evolve. I have known people, plus myself, some people they become so competent in Python. Basically, once they were trained with us, they are now capable of creating Python solution like in few hours, and they can keep using that solution for many years to come. Plus, they can update those types of solution they are creating as constantly as they wish to. There are softwares in oil and gas industry, basically analytical softwares, or let's say simulation softwares that basically they connect to Python seamlessly. These technologies are TechLog, Olga, Pipesum, Petroleum Experts IPM package, or the integrated production management package. We have the Geolog, we have the T Navigator, and we have lots and lots of software. They are lined up to convert into Python because it's easy. Lots of people started suddenly using Python. So that's why basically you now start to see Python everywhere, because it's easy and everyone is adapting it. You can do lots and lots of analytical examples, or let's say empirical analysis with Python. You can do you can do reservoir engineering applications like PVT, decline curve analysis, fracture design, petrophysics. You can do some surveillance with this. You can do grid mapping. You can do advanced XY plotting, or you can even create a more customized and advanced bubble maps where you have different colors and different basically shapes denoting different wells and whatnot. You can create different quadrant plots that basically analyze multiple values at the same time. You can create machine learning algorithms that basically takes up and eats up your wells and convert those into smart models, and basically they predict which wells are good and which wells are bad. Plus, you can also use Python for simple simulations like material balance simulation or flowing material balance simulation. Some people also use material Python to create a one-dimensional simulation. And the most important part of Python, it can connect to oil and gas industry software. For example, if you decide to connect Python to Prosper or Gap, what you can do using Python only, you can inject or you can simulate different values and different data from Python and basically push that into Prosper. This is going to be very, very fast. It's going to collect huge volumes of data for you. And this is unfortunately not possible if you use the software interface alone. But whenever you combine this with Python, you will get a huge tool and a very powerful tool. Basically, it can do lots of analytics and analysis for you. That's enough talking. So let me show you what you can do in Python the easy way. But basically, there are lots of things that you can do with Python, and I mean a lot of things. Okay, so one of the things that you can do with Python is to create something called data applications. Okay, so before we start showing you that data application, let me introduce you to the basic, or let's say the core technology that's going to be discussed in the training that we're going to start in the upcoming 10 days. Okay, so the core technology that basically it allows us to work with data is called SQL Server, or let's say let's call an SQL database. So let me show you what an SQL database is. And in the upcoming 10 minutes, I will show you the basic things that you can do with an SQL server. An SQL server, or let's say an SQL, is actually it's not a language. It's not an actual programming language, but it's a language that was designed in the 70s in order to allow engineers and software developers to actually to interact with databases. So let me show you an example. So if we decided to open up, for example, let's say Excel sheet, right? Let me show you the core problem with these types of things. So let's say that this is our Excel sheet, right? Just take a look at this Excel and how many columns it contains. So now, do you guys know the limitations for Excel sheets? Do one of you guys, any one of you guys, by any chance knows the limitation of rows on Excel sheet? Well, as the documentation says, the Excel sheet has a little bit over 1 million row record limitation. So what this means is if you're working with any type of data acquisition or you're working with any type of large volumes of data, you cannot save more than 1 million rows in Excel sheets. And even if you do so, if you go maybe past 100,000 rows or 200,000 rows, your Excel sheet becomes a lot slower than before. And basically, it is going to be unworkable with. So let's say that maybe you want to filter down any particular well. What you usually do in Excel sheet, basically you're selecting those columns and then go to data and then activate the filter, and then maybe you can select any well you want, right? This is what usually happens in Excel sheet. But this process is very slow. And the process of filtering down multiple things at the same time or chaining multiple things at the same time, it's going to be time consuming. Plus, it's not very easily shareable among other people. So let me show you the alternative thing that you're encouraged to if you use database servers. So a database server is what hosts your data in an organized container. We know this as a database, okay? So let's say that we have a database which is called OilDB, and the OilDB is just basically it's a container that contains multiple tables. Each table can be thought of as an Excel sheet of its own, right? For example, let's say we want to take a look at the XY table. In order to take a look at the XY table, what we're going to do, we're going to do something like select all from XY. So basically select all is basically one of the oldest commands that you can do in SQL. Once you do this, when you click on execute, you will get all the data. And you can see the execution time, it's blazing fast because this software is basically designed to work with large volumes of data, right? Now, just remember, whenever we worked with Excel, we will click on any column explicitly to create a filter, basically to reduce down our data, right? But in SQL, you don't need to do that. There is a command that basically filters down these things for you. For example, You can have a where command, or this is a condition. Basically, it reduces down a particular thing for you in the data. For example, let's say that we only are interested in wells. For example, the completion date for these wells are later or greater than, let's say, 2001. So anything beyond 2001, we're interested in. Just like this, we'll click on execute. There we go. Now you only get the data that are basically from this era only, or from this decade only. So basically, SQL will allow you to significantly and hugely control the data in an easy manner. Lots and lots of oil and gas companies are using something called an SQL server, which is something that you are seeing now. Okay. And let me show you how we can connect a software called Power BI, which is covered in our training. How you can connect Power BI into this SQL database. By the way, SQL database can be hosted on your PC, or it can be hosted on a something called a server, where your company actually pays some money or some fees to companies to host that database for them. So basically, this database can sit in multiple places. Okay, but the main concept is the same. So let me show you how we can connect to our database and basically get the data, right? So let me show you. So one of the things that we can do is we can open up Power BI. By the way, later, once we finish working with Power BI, I'll show you how to create some solution around Python as well, and how we can basically connect everything together. In Power BI, Power BI is known as a business intelligence tool. A business intelligence tool is a tool that allows you to create a data-driven analysis. A data-driven analysis is basically you create visualization and analysis and predictions around your data. So this is basically the whole concept. And basically, Power BI can integrate very nicely into Python as well. So let me show you how we can connect to the database. In Power BI, you can go to import data from SQL, and you will type the name of the server, and name of the server is called SQL Express, and this is usually called Express if you're working on the free version. And the database name is called OilDB2, and you will click on OK. Once you click on OK, now you are going to get all the tables that exist in this database. Now you can see how easy this is. And instead of just going ahead and opening each file separately, all of these things exist in the Excel sheet, or in the SQL server. You can select anything. For example, I can select the production table, the injection table. I can select off the pressure table, the XY table, and so on and so forth. Plus, also I can select something else like the category table. Once I click load, 5 or 4 tables will be added to my project, just like this, in just less than a minute. These types of tools actually are built to make your life easier. So let me show you how. These types of tools actually, they basically built around statistics. For example, if you want to create a totals of your production, but the totals of the production you want it to be, for example, interactive, that's just okay. You can do that. For example, let me show you. There is something called a decomposition tree. A decomposition tree is basically something that you use to explain some value by something. So let me show you. If we add the decomposition tree is empty. Okay, maybe you want to explain the production by some particular category, maybe by some operator, maybe by some fiscal regime, maybe by some year. We can do all of these, by the way. For example, we are going to start with the oil production, or maybe we want to analyze the water production. Maybe let's see how much water this field is producing in total. You will drag and drop the water, and basically it will show you the sum of water. The sum of water, or the total water produced, is 750 million barrels. Okay, let's analyze, or let's diagnose where this water is coming from, right? Because this is just a single value. By the way, a single statistical value that combines everything together, this is known as aggregate. Okay, so let's explain this. We can explain this by further down explaining different categories. For example, we can drag and drop the name of the field and select of that field, basically it will show you which field is contributing to this water production. And right off the bat, you can see which one of these fields actually contributing more. Maybe this explanation is not enough to you. Maybe you want to explain which field is basically contribute, or which parameters are contributing to each particular field. What we can do is we need to add another explanation. Let's use the pool, or let's say use the reservoir to explain which pool is basically contributing to these water production. So we will add the pools. Once we add the pool, now we get an explanation further down which which pool actually is contributing to which field more. Okay, so let's say that we want to explain, or we want to see this VK1 pool, which let's say which entities are basically contributing to this pool. Now we will explain by zone. By the way, you can explain by any number of categories you want. This depends on your data. So let's explain this further by the zone. We will select the zone. Now we are explaining which zone is contributing to which pool. Whenever you click, you will get this interactive switcher. Basically, it switched down between different categories. So you can see how different zones are affecting the production of different fields. Okay, so now one final thing that usually left is to narrow down your sources on this particular zone on which well is actually contributing more. Now you will go ahead and add the well and basically explain this aggregation by well as well. You can see which wells are contributing more to this particular parameter, which is the total production from this well. Of course, you can do lots and lots of things around the data that you have connected with SQL. For example, you can create a simple line chart, and this line chart will be explained, or let's say it will be broken down by each particular well. So we will assign each well to a particular color. This is going to be very simple. For example, we can drag and drop the date on the x-axis, and we can drag and drop the oil on the y-axis. Now you will get a single, let's say a single line that basically represents your production, right? And what else you can do is, instead of just having a single line for your total production of the field, which can be average or summation or anything you want, what you can do is you can explain this line, or you can further break this line. So you can see, for example, basically which pool is basically contributing to this production more by just explaining this as a legend, or maybe breaking down this as a legend. Once you do that, you will get different curves basically contributing differently. Of course, if you have different scales of different, for example, pools, basically they have different scale values. What you can do is you can, of course, activate the logarithmic scale in order to make this a more of a friendlier chart. Let's say, for example, let's say that this is 300. And of course, you can make this as a logarithmic chart as well. You can explain this further down by instead of just showing the summation, you can show the average. You can average this down as well. You can apply actually lots and lots of filter on top of this. You can add lots of explanations. These types of software actually make your life easier by explaining data, or basically viewing the data differently than usually you do in Excel sheets. Okay, so let's say this is the first part of the session. Let me show you now how you can create solutions around Python. That was Power BI and SQL. Of course, everything is connected in data science and data analysis. Let me show you how we can create a solution in Python. In Python, you can do lots of things, by the way, and I mean lots and lots of things. Okay, so let me show you one of the things that you usually do. In Python, we have something called a no-code data analysis. So what is a no-code data analysis? A no-code data analysis is basically it's a library, or it's a piece of code that's ready to use. You can use that piece of code in order to, let's say, create data visualization and data analysis on the fly. There are lots and lots of libraries that can support these types of actions. And one of the libraries is called PyGWalker. PyGWalker is basically, it's a very good and infamous library that you can use. So let me show you. So if you go to Google and type PyGWalker, basically PyGWalker, you will feed PyGWalker a table, and it will take, basically it will feed up on your table, and it will convert that into an interactive solution. So let me show you. So this is the main website, and basically you can create these different solutions with PyGWalker. For example, you can create data visualization, you can create data analysis with it. Basically, you can select off different data and so on and so forth. So this is what's related to PyGWalker. There is another solution that you can use in order to analyze data, which is called MitoSheet. MitoSheet is something similar to an Excel sheet, but that particular Excel sheet is in Python. You can use that particular thing in order to create interactive and advanced visualization in Python. Plus, there is another thing that you can use Python for, which is called a heat map. A heat map in Python is something that you usually use in order to create a particular visualization. So let me show you an example. So let me just copy paste a little bit of data. So this is basically the data I have. Basically, I am pulling data from an Excel sheet. And this is a possibility, by the way, in Python. You can pull data from different sources. And in this data, what we have this data. If you print down the name of data, we can get a view of the data, by the way. So basically, if you run this, you will get a sample or the snapshot of the data. And basically, the way you get the data and the work with the data is going to be a lot faster than working with Excel or any other type of software. Okay. In this data, we have a column called well name. So if we copy that particular column name and basically paste the name of the column, now suddenly we are getting a single column. This column represents all the wells that are contributing to this data sheet. If we use or get the unique wells, we're going to get a short list of all the wells that we have basically contributing to this data. What I'm going to do now is, let's say that I am interested in one of these wells. Okay, so let's say that we're interested in the first well. So we're going to create a simple, let's say, filtering for our well, which is, let's call this well equals to data. And basically now we are going to filter down or reduce down for our data based on this particular well. So let me show you. And this is going to be based on the well. And I'm going to show you the data that will be generated. There we go. Now we have generated a new table. By the way, the table that you generate now, basically you can export this table to a different place. You can export this back to Excel sheet, or you can export this to CSV. Of course, you can use this, for example, with an interactive visualization as well. So let me show you how we can create an interactive visualization by using the PyGWalker. So we can import PyGWalker as PyG, and then pyg.walk. Let's take a walk with the data of the well. Let's run this. There we go. Now you have a full-fledged interactive visualization in Python, and this is, of course, free to use, and you don't have to pay a penny in order to use it. This opens up a visualization that basically looks like Tableau software. So let's say that we want to create a simple chart, right? So what we are going to do is we need the X and Y, and I will choose the date to be the X. Just pay attention that I'm using drag and drop. There is no need to write fancy codes, by the way. Plus, I can also, what I can do, let's say that I'm interested in analyzing the wellhead pressure. I will drag and drop that to the y-axis. There we go. Now the chart already showed up. I can, of course, change the aspect ratio of this plot. I can change the width by the height. I can make this any way we want. Now, basically, this is for one of the wells only, because this is the data that basically comes from one of the well only. And you can feed any data you want. For example, I can redo this, or let's say I can create another visualization, but this time let's use dot walk with the full data, which is going to be called data, right? So this is going to be two different visualizations at the same time. So the above visualization, let's say this is going to be for the first well, and the other visualization, it's going to be, let's say, for the full wells. So by the way, you can just go ahead and click on edit, and then you can call this any name of the well you want. For example, let's call this well one. Now the name of the visualization is called well one, and you can rename the other one to all wells. So let's call this all wells and confirm that. And there we go. Now we can start doing our analysis for all the wells. We can drag and drop the date on the x-axis, and on the y-axis, let's use the wellhead pressure. And we can explain this by the name of the well. For example, let me show you. We can use the wellbore code or the wellbore name in order to break down this chart by color. Once we do this, now we get different wells basically contributing to this chart. And of course, we can change the aspect ratio to make this a lot bigger as we wish. There we go. Now this is what the chart looks like. Of course, you can use different things as well. For example, you can use the size, or let's say the shape of the scatter, or the size of the scatter to explain a different parameter. For example, maybe I want to explain the volume of the water based on the opacity. So the lighter it is, it's going to be different, denoted to different thing, and the darker it is, it's going to denote a different value. This is regarding the water volume. You can also use the size, which is going to be the scatter size. You can use the shape or the details. Basically, you can break down this by anything you want. Of course, you can select as well any well you want during the analysis. That's going to be used in the filter. You can change the chart type and the shape to anything you want. For example, you can use area chart. Area chart can be stack chart, or it can be any transparent chart you want. You can use scatter chart, just like this. This is all without even writing a code. Of course, you can write the code if you want to. So let me show you an example. I will show you how to write a code that basically predicts, let's say, water oil ratio, and basically how water oil ratio changes with time. Okay, so let's say that we have this well. Okay, so let me show you how we can create a chart around this well. Okay, so let's do plt.scatter. So this is going to create a plot for us. And I am going to use the date of the production on the x-axis, and on the y-axis, I'm going to use the oil. Let's say that we want to use the the water ratio, or we can use the water oil ratio. So let's just copy the name of the variable that basically holds water for us. So let's copy that and paste it. So let's generate the scatter plot. There we go. This is what the scatter looks like. And this is what let me show you what we want to do. Let's open our drawing application. So this is our water production. Usually in oil and gas industry, there are something called empirical models that we usually use in order to predict the let's say, or analyze the production of a particular KPI or a particular parameter. One of the hardest things that we usually predict is called the water rate, or the gas rate, or the GOR, or the water rate. Usually the prediction of these things are somewhat hard to do, because there are no satisfactory empirical model that basically satisfy these types of prediction. But luckily in Python, we have something called data series analysis or time series analysis. We have something particularly called autoregression. What autoregression does, it takes a look back, for example, 10 data points or 20 data points. And once it looks back 20 data points, it understands how the data is changing with time. Once we understand, or let's say once Python understands how data changes with time, what it does, it starts to predict those parameters for us with the future. So let me show you how we can create a solution that basically harnesses the power of Python in order to analyze those types of time series analysis or time series trends. Okay, now this is the historical data, right? Next step is to actually to create, let's say, a time series analysis that basically that's going to predict for us how much basically production of water that we're going to have in the upcoming future, right? We can do anything we want. Okay, so let me show you. In order to make this work, what we are going to do is we're going to create basically a time series analysis that's basically going to be, let me just copy some of the code because I don't want to waste your time just typing code. Okay, so let's do this. And now let me show you how we can prepare the data for the time series analysis. Okay, so I will be creating a variable called water equals to well, and I'm interested in the water volume, just like this. Let me copy that and paste it. Once we do that, let's make sure that on the x-axis we have the date, okay, which is very important to us. So water.index equals to well dot date PRD. Let me print down the water for you. There we go. Now this is what the water looks like. And let's just view a sample of the water. So let's like 30 lines. There we go. This is what the water looks like. Of course, you have lots of zeros. Means that there are no production or there is no water being produced. But looking what the data looks like, this is just a no production. This is what the data looks like. Now on the let's say on the x-axis we have the date, and on the y-axis we have the water values. Let me show you how we can train our Python in order to understand the different patterns we have. Okay, so we are going to create a model that basically will understand our data, so we can basically generate new data, right? So model equals to auto regression that we have just created. We open and close parentheses. In this function or in this model, we need two types of data. So the first data, we need the water rate that we want to predict. By the way, you might already know it's not only about water. You can create a prediction of anything you want. For example, you can create a prediction for bottom hole pressure. You can create a prediction for wellhead pressure, temperature, different things that change with season. You can do anything you want, okay? And now the next input will be is how many data we want to look back for our prediction. Now let's start simple. Let's start with 5 data points. Of course, the more data points that you look behind, the more accurate your result is going to be, okay? But the slower the model will understand your data. So model equals to, now let's train our model dot fit. Now we are training the model. Once we fit, you will see that the model is already run. And let me show you the data that was predicted. Model.fitted values. Let me show you. There we go. Now these are basically the values that were predicted from this model. Now let's plot this back, or let's plot back these predicted values. So let's do values equals to model.predicted values or fitted values, just like this. Now let's plot these against the historical data. So this is going to be plt.plot. Let's do a nice plot. So values dot index and values, let's say dot values. Let's run this. There we go. Now this is the fitted data. Let me change the color. So let's change the color of the line. Let's change this to navy blue. There we go. Now this is what your data looks like. And these are the blue line is the predicted line. And those dots are the actual historical dots. Okay, so now the model learned our data very, very well. Of course, if you look back more to this data, so let me show you, we can copy this model, the full model that we just created. We just can copy paste this few times, and in the second model, I can take a look at back 15 data points. So the model learns a little bit better, and the second model or the third model will take a look at 30 points in the previous history. So basically, it learns this a little bit better. So the last one will be green color, and the other one will be red in color. Oh, let's make this a different one. Let's make this magenta. Of course, you can control any aspect of your chart. And these are the different data models that basically plotted with each other. So let me show you how we can view this interactively so we can see how the prediction is doing good or not. So let me show you. We can do an outside plotting using the QT functionality. Let's see. Yeah, for some reason is not plotting these. Let me just put these on the top. Let's run these, and yep, still the same thing. Let me copy and paste these to a let's just show these as an inline chart. Now let me show you how we can do, or let me show you how we can do a different thing. For example, let's open that back again. There we go. Let's run this again. There we go. It looks good. Let me show you how we can predict the future values, because so far we have trained our model on the previous values. Let me show you how we can predict the future ones. Okay, so the future one can be predicted by using model dot predict, and using this predict function, you can predict any period you want. For example, you can predict based on a particular time. Maybe you want to predict based on a particular, for example, values. Maybe or you want to predict on a particular period. Maybe let's provide period equals to, for example, we want to predict 10 periods. Let's do periods. Or you can do something like start and end for your prediction. So let's do start. For example, start. This is going to be the starting time of your prediction. And this can be the starting time of your prediction. It can be anything you want. For example, you can predict, let's say, the starting of your prediction to be, let's say, 2017, or depending on the data, 1. And the ending of your prediction to be, for example, 2018, 01, 01. You will get new data based on this prediction that you're generating. And you can, of course, just plot these back again. Because what you're going to get different values based on your prediction. So let me save those values as predicted. And of course, you can push back those again into plotting. So plt dot plot. We can plot these back again. Let's do a prediction. It says that prediction is not defined. So let's run this again. There we go. Now this is what our production looks like. Why it's behaving like this? Because the production originally had oscillation in it. So that's why it's predicting just like this, because we have different oscillations in our prediction. Let's narrow down the prediction from 2016, 04 let's say 30th to 2017, January 1st. So let's run this, there we go. Now different predictions you have. Of course, you can just view the data as well. Now this shows you down the data. And maybe you want to calculate the cumulative production that will come out of this prediction. That's also very easy to do. Let me show you. So maybe you want to see how much, basically, how much barrels of water you are going to produce based on this chart, right? So let me show you. You will do something like dot sum. Basically, it will show you the summation of production of water that is going to happen during this period. So this is the summation of water production. This is just the summation, right? So let me show you one more thing. You can, of course, convert this into an actual table, and you can export this table for your use as well. So we are going to do something like data frame. We're going to create data frame around our prediction, just like this. So this basically will do the date and the actual prediction. You can, of course, add a new column to this that's going to be the cumulative production based on our data. So the cumulative production equals to data frame of column 0, or this is going to be the first column, dot cum sum. So this is going to be the running summation of the cumulative summation. So let me show you how we can plot this. We can plot this easily. Just copy these and paste this plot, and we're going to do data frame.index with data frame of the historical data or the predicted data. Now let's do another plot. This time this plot is going to be for our the cumulative production, or how much we produced total during this time, which is going to be the Q. Okay, so let's run this. It says that we have an error in the name of the column. So let's correct that. So data frame. Let's do prediction. So let's check now the values. Let's see if those are working just fine. There we go. Now we have our values and we have our cumulative things. So let's put these back again into work. So we can have the cumulative production against the predicted instantaneous values, which are the daily values. So let's push these. There we go. Now this is the cumulative production, and this is the actual production. Of course, you can make these as a log chart. So plt dot y scale. So we can make this simply as a log chart or semi-log chart. Now this is the blue one is the production cumulative, and the red one is the cumulative or the actual production that was oscillating with time. So yeah, that's what we have so far to be presented. And please, if you have any question regarding whatever presented in this session, please feel free to ask. And I would like to thank you all for your patience and being good listeners. Thank you.